Welcome to Brain Vision.
Hey guys, let's do problem 88. We need to estimate the volumetric flow rate of oxygen. We know from the compressibility factor equation of its state, PV is equal to Z nRT, or the volumetric flow rate is equal to Z nR T divided by pressure. Since oxygen is compressed and no reaction takes place, therefore we can obtain the ratio of outlet and inlet volumetric flow rates as we can obtain this as V2 divided by V1 is equal to P1 Z2 into RT2 divided by P2 Z1 N1 RT1, or we can write the volumetric flow rate V2 is equal to V1 P1 Z2 T2 divided by P2 Z1 T1. In this case, the gas constant and number of moles, these are constant, therefore we can use this relationship. Now the critical temperature and pressure of oxygen is, the critical temperature is 154.4 Kelvin and the critical pressure is 49.7 atmospheric pressure. Now we need to calculate what are the reduced temperature and pressure. Let's do that. Now the reduced temperature at the inlet, it is temperature at the inlet divided by the critical temperature, therefore 298 Kelvin divided by the critical temperature 154.4 Kelvin, or the reduced temperature at the inlet is 1.93 and the reduced pressure at the inlet is the pressure at the inlet divided by the reduced pressure, therefore 1 atmospheric pressure divided by 49.7 atmospheric pressure, which gives us 0.0201. And at this reduced temperature and pressure we get the Z value, Z factor as 1.0. And then we need to calculate what is the Z factor at the outlet. At the outlet the temperature is 358 Kelvin and the temperature, critical temperature 54.4 Kelvin, therefore the reduced temperature is 2.32, and similarly the reduced pressure at the outlet is the pressure at the outlet, which is 1000 atmospheric pressure divided by the reduced pressure 49.7, therefore we get 20.1. and at this reduced temperature and reduced pressure we get the Z value as 1.6. Now we can use that volumetric flow rate equation. The volumetric flow rate at the outlet V2 is equal to V1 P1 Z2 T2 divided by P2 Z1 D1. Let's insert all the values now. The volumetric flow rate at the inlet is 127 meter cube per hour. The pressure is 1 atmospheric pressure at the inlet, and at the outlet it is 1000. The Z factor at the outlet is 1.6, at the inlet is 1. Temperature at the outlet is 358 Kelvin and at the inlet is 298 Kelvin. Therefore, we get the volumetric flow rate at the outlet is 0.244 meter cube per hour.